Hello everyone. I welcome you all to this digital classroom for the subject digital image processing. Today, let us solve few example problems related to histogram equalization. You can take down this question. This question has been taken from VTU University question paper, which has appeared during Jan 2019 as well as July 2019. It's a very important university question. Given a 4x4 image having a grayscale between 0, 9. Perform histogram equalization. And draw the histogram of the image before and after equalization. So the 4x4 image given here is as shown below. The first row we have 2, 3, 3, 2. In the second row we have 4, 2, 4, 3. And in the third row we have 3, 2, 3, 5. And at the last row we have 2, 4, 2, 4. So you are given with an image of size 4x4. That is a small image segment is given to you. Having a grayscale between 0 to 9, which means the grayscale ranges from 0 to L minus 1. So the maximum range here is given here as 0 to 9. Hence, it is very clear that L minus 1 equals to 9 in this case. So let us extract the given data. So L minus 1 is equal to 9 and you have been given with an image segment of size 4x4. And let me continue reading this question. Perform histogram equalization and draw the histogram of the image before and after equalization. So we have to perform histogram equalization and we have to draw the histogram before and after equalization for a given image segment. So let us solve this problem. Solution. So let me write the given data. Given 4x4 image. Hence, it is very clear that M cross N will be equal to 4x4, which is nothing but 16. That is the total number of pixels in this given image segment equals to 16. The image size is 4x4. So if you count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. So the total number of pixels will be equal to 16. That is nothing but M cross M. And apart from that, you have been given with the gray levels which is ranging from 0 to L minus 1. That is 0 to 9. Hence, L minus 1 equal to 9. So we have extracted the given data. Now let us write the formula to calculate histogram equalization. So the formula to calculate histogram equalization is given by Sk, that is the output, which is equal to the transform which you are going to apply over the input image for a particular pixel Rk. Hence, I can write it as Sk equal to L minus 1 into summation j is equal to 0 to k PR of Rj, where k represents the gray levels. So from the given image segment, first let us represent it in the form of a table. So let me formulate the in the first column. Let me represent it as gray level. That is nothing but Rk. And in the second column, let me represent it as number of pixels. As you know that histogram is a plot with respect to the gray levels against the frequency of occurrence. That is nothing but the number of pixels nk. So it is very clear that the gray level ranges from 0 to 9. So first let me represent the first gray level 0, and the number of occurrence for this gray level, it is not seen in the image segment at all. So nk will be equal to 0. Moving on to the next case, the frequency of occurrence of intensity level 1. You can just notice in this image segment, 1 has not occurred, not even once. Hence, the number of pixels for the occurrence of 1 is 0. Then let us check for the grayscale 2. The number of occurrence for the grayscale 2, you can make a note of it here. That is 1, 2, 3, 4, 5, 6. So the number of times a particular gray level 2 has occurred is here 6. Let me continue. Let us check for intensity level 3, 4, 5, 6 and so on. The frequency of occurrence of the intensity level 3, 4, 5, 6, 7, 8 up to 9. 3, 4, 5, 6, 7, 8 and then finally 9. So the frequency of occurrence for intensity level 3, let me check out here. The frequency of occurrence of intensity level 3, we have 1, 2, 3, 4, 5. So intensity level 3 has occurred 5 times. Let me write it here. Then let us check for the intensity level 4 and its frequency of occurrence. Frequency of occurrence for intensity level 4 is 1, 2, 3, 4 and 5 is 1 time. 4 has occurred 4 times and 5 has occurred 1 time. 4 has occurred 4 times and 5 has occurred 1 time. Rest of all the intensity level 6, 7, 8, 9 has not occurred at all, so I can make it as 0. So just I have transformed for a given image segment in a form of a table, and we have formulated the table in such a way that we can draw the histogram before equalization. Once after filling these two columns, now it is ready to represent the histogram before equalization. So we know that a histogram is a plot with respect to the gray levels Rk against its frequency of occurrence Nk. So in this example, gray level ranges from 0, 1, 2, 3, 4, 5, 6, 7, 8 and 9. And frequency of occurrence of 0 is 0 times, and 1 has occurred 0 times, but 2 has occurred 6 times. Frequency of occurrence for the intensity level 2 is 6 times, and the frequency of occurrence for intensity level 3 is 5 times. Intensity level 4 is 4 times, and frequency of occurrence of intensity level 5 is 1 time. 5 has occurred only once, so we can write it as 1 time. Make the divisions here: 2, 4, 6, 8, 10. So this is a histogram for a given image before equalization, before performing equalization. The next column which you are going to fill here is to calculate the probability density function. So the probability density function PR of RK is given by NK divided by M cross N. Let me explain you this with a simple example. The probability of occurrence of head and tail, head or a tail while tossing a coin is given by the probability of occurrence of head is given by 1. That is, from the coin, the only possibility is 1 divided by the total number of possibilities in tossing a coin is either it can be head or tail. So 1 is the occurrence for suggesting for head to appear, 1 divided by 2. Similarly, the probability of occurrence for a gray level 0 is given by number of times a particular gray level has occurred divided by M cross N is nothing but total number of pixels. So first let me total the number of pixels. Total number of pixels M cross N is, let me sum up all. In the beginning itself I told you, as it is a 4 cross 4 image, so we will be having 16 pixels. So for the first case, 0 divided by 16, that is nothing but 0. And for the second case, the probability of occurrence for a particular gray level 1 is given by 0 divided by 16, again 16. Then the probability of occurrence for a particular gray level 2 is given by 2. For a particular gray level 2 is given by NK is 6 here, 6 divided by 16. Hence, we get 0.375. And the probability of occurrence for an intensity level 3 is given by 5 divided by 16, that is 0.3125. And for the probability of occurrence for a particular gray level 4 is given by 0.25. Then for 5 it is given by 1 divided by 16, hence we get 0.0625. And for rest of all the cases it will be equal to 0. So now let us apply the formula where Sk is given by L minus 1 into summation j is equal to 0 to k PR of Rj. Let me write for the first case when k equal to 0. S0 will be equal to L minus 1 into summation j is equal to 0 to 0. The maximum limit is 0 here for k equal to 0. PR of Rj. Hence, we know that L minus 1 is 9 in this case. So 9 multiplied by PR of R0. So 9 into PR of R0 is nothing but the first case, the probability of occurrence of a gray level 0 to appear. So in this case it is 0. Hence S0 will be equal to 0. Then for the next case, if we substitute for k equal to 1, then the small change in the formula is given by L minus 1 is equal to summation j is equal to 0 to 1 PR of Rj, where L minus 1 is 9, then summation j is equal to 0 to 1 PR of Rj. Hence I can expand this expression as 9 into PR of R0 plus 9 into PR of R1. As we know from the previous case, 9 into PR of R0 is nothing but 0. 0 plus 9 into PR of R1 in this case is again 0. PR of R1, that is the probability of occurrence for 9 into 0. Hence we get 0. So instead of expanding the summation for each cases of k, let us follow a shortcut. Just continuing in the same table with 2 steps. The steps are very, and let us multiply the previous column by L minus 1. In this case, L minus 1 is 9, remember. Then 0 into 9 is 0. 0 into 9 is 0. And 0.375 into 9 is 3.375. Then let me multiply 0.3125 into 9. We get 2.8125. And for the next case, 0.25 into 9, we get 2.25. And for the next case, 0.0625 into 9, it will be 0.5625. And then finally 0 into 9, 0, 0 into 9, 0, 0 into 9, 0. For the rest of all the cases, it is 0. And then let us calculate the running sum, that is finally SK. Sum is nothing but just we can take the previous column, the first element is 0 here. Then let us perform running sum as follows. 0 plus 0 has to be filled in the second column. That is 0 plus 0 is 0. Now you can perform running sum with the next element. 0 plus 3.375. So we get 3.375. As I have justified already here in this case, we just multiply with 9. Then we are performing the running sum. 0, the previous case, added up with the second case when you are considering for k. When k is equal to 2, we take the previous sum added up with the next case and it goes on. So to make the procedure very simple, we can perform this running sum procedure so that we can do it very easily and we can complete this problem in a very short duration of time. 3.375 plus 2.812 will be equal to 6.1875. 6.1875. Then again perform running sum. 6.1875 plus 2.25, we get 8.4375. And in the next case, 8.4375 plus 0.5625 will be equal to 9. Then 9 plus 0, it's 9. Again perform running sum. 9. This will be 9. 9 plus 0, 9. 9 plus 0. So let us round off SK. As SK again represents the gray levels after performing histogram equalization. And it cannot be in decimal value. So 0, 0, 0 rounded up to 0. 3.375 can be rounded up to 3. 6.1875 can be rounded up to 6. 8.43 can be rounded up to 8. Then 9. We get 9 here. Now we have to plot the obtained grayscale, that is SK, against its frequency of occurrence MK. So to make the procedure very simple, just I copy paste the second column and I paste it here. 0, 0, 6, 5, 4, 1, 0, 0, 0, 0. Now we are done with this table. It is very clear that if we compare the first two columns, with the last two columns. The first two columns represents a table for the histogram before equalization, and this is going to be the table for histogram after equalization. Let us have a keen observation on it. In this case, 0 has occurred 0 times, and 1 intensity level 1 has occurred 0 times, whereas in this case 0 has occurred 0 times. And here in this case 2 has occurred 6 times, whereas in this case intensity level 3 has occurred 6 times. And here in the given image segment 3 has occurred 5 times, whereas in this image segment 6 has occurred 5 times. So 3 intensity level 2 replaced by 3 and intensity level 3 replaced by 6. And 4 has occurred 4 times in this example, whereas after performing equalization 8 has occurred 4 times. And here in the before histogram equalization 5 has occurred 1 time, whereas image segment 9 has occurred 1 time. And 6, 7, 8, 9 has not occurred at all. And whereas here again in this case 8 has already occurred. So have a comparison and let us plot the graph for histogram after equalization. So it always gives a good presentation when you try to draw the graph directly below the histogram before equalization. So this is a simple thing, is k against nk, and the grayscale ranges from 0, 1, 2, 3, 4, 5, 6, 7, 8 and 9. This really gives a very good comparison between histogram before equalization and after equalization. So in this case 3 has occurred 6 times. Intensity level 3 has occurred 6 times, and intensity level 6 has occurred 5 times. Intensity level 6 has occurred 5 times, whereas in this case intensity level 6 has occurred only 0 times. Then intensity level 8 has occurred 4 times, and intensity level 9 has occurred 1 time. 2, 4, 6, 8. So this is a plot before performing histogram equalization, and this is a plot of the histogram for the given image segment after performing histogram equalization. Let me write this as histogram after equalization. From the input image segment, 2 is replaced by 3, 2 replaced by 3, 3 replaced by 6, 2 is replaced by 3, and 3 is replaced by 6. And 4 is replaced by 8, and intensity level 5 is replaced by 9. 4 is replaced by 8, and intensity level 5 is replaced by 9. Hence, the output image segment will be, let me replace all 2 by 3 first. And then 3 replaced by 6, hence let me replace 3 by 6. Then intensity level 4 replaced by 8. Let me replace all intensities at 4 by 8. And finally intensity level 5 replaced by 9. So this is your output image segment after performing histogram equalization. Hope you have understood this problem. In the next lecture, let us solve few more problems related to histogram equalization. Thank you.